Okay, so yesterday I tried to make a video and it failed. I can't wear that, so the sound is going to be horrible. This microphone is terrible, but I am having problems technologically. I have had problems with this computer since I owned it last year, making videos. So I do like making note videos, and hopefully this works out, and hopefully you can hear me most of the way. All right, let me get my fat head in the corner here. Oh, look at those wrinkles. What happened? Anyway, um, then I notice that when I turn away from the screen, you really can't hear me. So I got to really talk towards this. But I can, right? Don't we always say I can statements at Lockport? Yay. There's a bunch of crap. We can do attributes of graphs, which the 2AP video, she talked about that. Increasing, decreasing, maximums, mins, x-intercepts, y-intercepts. Then we're going to do limit notation, blah, blah, blah. Then we're going to talk about what's called average rate of change. First video, equal x values. What's the y? What's the slope? It's a slope thing. Then we're going to graph quadratics. Honestly, at the end, I didn't have enough time to do that, but I mentioned some of the attributes you should remember from last year. We literally graphed quadratics probably 11 months ago in Math 2 Honors. And then I think I'm going to have to wait for this for Monday to clean this off, first and second order differences when you have a list of data. Okay, so the first one, I'm just going to shove the answers in your head because you should definitely know this. All right, but go ahead and put that real quick. This is an absolute maximum because it is the highest point overall, biggest y coordinate of that graph. It is 5 when x equals 5. Unfortunately, those are the same values, so you don't get, I wish there were different x and y values, but you say the y value is the max. It's located at x equals 5. I hope you remember that from last year. This is just a local minimum, so it is 2 when x equals 2. Again, unfortunately, they're both the same number. So a little bit better on the minimum. There is no absolute minimum because this goes forever down in both of these pieces. So the minimum is negative infinity, which is a number that doesn't exist, goes forever down. But we do have a local, and then it's a little estimate. So that's a little bit better. It is 1.8, the y. My bad, dogs. Fourth hour didn't say a dang thing. Isn't it negative 1.8, right? And then it's located at x equals 3.2. So that's easy. All right, what's not easy is I think this might be brand new. I can't quite remember if I talked about even and odd last year. And even if I did, if I don't remember if I did, you probably won't remember it, even if I did and it was probably one day. So here's what you got to highlight. And this would be smart with notes that are really shoved at you with a lot of words. Let's highlight the keywords. And then maybe later, if you want to read all the stuff in there, fine. We don't have time to note it all in this not a shortened period. I did do 10 minutes of AP videos. So, all right. So an even function is a function that's symmetric with the y-axis. It's very specific. But actually what's true then is this. If I plug in x, I get a y. If I plug in the opposite of x, I get the same y. That's what negative x, f of negative x, they're in the same position as f of x. That's the same y coordinate. So that is what's called the algebraic representation of even. And I know that's listed up there in the definition up there, but what I'm going to do is take this equation. By the way, this equation is this graph. And how do I know that? You better darn well know that x squared is a parabola, and then plus 1 means it's moved up 1. All right, so its vertex is 0, 1. So that's the equation. But here's the algebraic proof or test that this is also even, which is symmetric with the y-axis. I'm slowing down to make sure I'm saying the right things. You actually plug in negative x for x and reevaluate the scenario. By the way, what's a negative x squared? Or what's a negative x times a negative x? What do you get? Positive x. So what this means is there's no change after you made that algebraic test, I guess you could say. So since there's no change, that's the algebraic proof that this equation must be even, and therefore the graph would have symmetry with the y-axis. It's all intertwined. Odd is origin. So highlight that real quick as the keywords in his notes, because this is an obscure thing. A lot of times students forget this stuff. And then they just come up from here or there. Okay, no, when I should have done this, those that had me last year, that's my symmetry sound. All right, there's a reflection across the y equals x line. But now for odd symmetry, reflected across the origin, we have a symmetric point that exists, a reflection of the other point. Here's this one. Those two little max and mins are relative max and mins or local. Okay, so the test for this is written up there, but I'll write it again. When you plug in negative x for x, you get the opposite. Or let's say this, let's make up points. Let's say this was 2 comma 8. By the way, that's 2 cubed. So I'm pretending it's y equals x cubed, which is a common odd function. And then what's negative 2 cubed? What is negative 2 cubed? Negative 8. So when I plug in the opposite of x, I get the opposite of the y coordinate. That's what those 2 points actually show. So I was just giving that up. But that actually is a lie. Erase these coordinates because this picture is actually this equation. So, I was just giving a point of what this means in context if we had numbers. So get those numbers out of there. Those coordinates are lies for the equation. But here's what's true about the equation. When I plug in negative x for x, yes, this equation makes this graph. When I plug in negative x for x, wrong, minus negative x. What do I get? Well, let's evaluate first of all. What's a negative cubed? Negative. Good. You're better than fourth hour. Fourth hour doesn't say a word. Wait, didn't I yell at you guys for being too quiet? You just did a reversal. All right. And then minus negative is plus. Now, when you look at this new function, every term is the what? Starts with an O. Opposite. Or I could rewrite this factoring out a negative, but that's what ended up happening. So when I plug in negative x for x and I get the opposite of my function, then that's the algebraic proof of odd. All right, I'm going to move on. Too much time on even and odd. Next thing you're going to have to do for attributes is find x and y intercepts. Come on. You should know for an x-intercept, you plug in 0 for y. For a y-intercept, you plug in 0 for x. The y-intercept is easy here because when I plug in 0 for x, I get 1. So that's why I wrote that already. What's weird is the x-intercept plugging in 0 for y. A weird example to show, because then when I subtract 1, hey everyone, what's the square root of a negative? An I number. Does that mean it's an x-intercept on a real coordinate plane? No. So this would imply that there's no x-intercept in this case. But at least I went through the idea of how do I find it. I just don't have one. So it's okay. And that can happen. The reason is, look at, there is no x-intercept. This is moved up one. That was actually this picture. There's no x-intercept. So you can see that. I just realized that. I didn't realize that last hour. Okay. Unfortunately, this is a little out of sync. It's kind of related to what the lady did with the rise and run, but she didn't have any numbers. What I'm trying to find is rate of change between 2 points on a graph. So that's what average rate of change is. You can see that right up here. That's just the slope formula. Okay. So if you could just bear with me. First of all, what is this first equation? A picture of what? What is that a picture of? 3, 2, 1, go. Line. So what you're going to find out is the average rate of change between any 2 points on a line will be the slope of that line. Because any 2 points that I pick on that line, the slope between those 2 points will be the slope of that line itself. All right. And that's what should be understood. But maybe don't get the grand concept of what are we doing with average rate of change. We're just picking 2 points and then we're finding the slope of those 2 points. That's the average rate of change between those 2 points. So I'm still going to go through the rigmarole. this is what I would have to do for any question like this. This is the x interval. So I want to find the average rate of change between -6 and 4 of this graph. I don't have the corresponding y values of these points, so I have to find them. Focus and pay attention. Input, say it. Output, I plug in -6. -6 times 7 is -42. -42 plus 10 is -32. And I'm going to prove that we end up getting 7 for the average rate of change. 4 for x. 4 times 7 is 28 plus 10 is 38. And then I find the slope between these 2 points. So I don't want to go ahead and graph the thing. I wish I could if we had time. And then you'll see why the answer is going to be 7. Average rate of change between 2 points on a line is the slope itself. 70 over 10. What's 70 over 10, everyone? 7. And that should have happened. The average rate of change between any 2 points on a line is the slope of that line. Okay? Now, I wish I could graph this or I had this picture. And I would probably, if I don't even have my graphing calculator because tech has not got that activated yet on my computer. But I would throw that on there and then show you between -3 and 2 what we could expect for a slope depending on where this parabola is. So just heed, we'll see it later when we, or maybe at least by Monday, I'll get a parabola, we'll do an average rate of change, and then you'll see what we're looking at on that. Actually, a little bit today, I think. So input, say it. -3 squared is 9. -3 times 4 is -12. -12 plus 9 is -3. Minus 2 is -5. Let me double check that real quick. 9, -12. -14 and 9 is -5. Okay, just want to make sure I did get that output right. 2 squared is 4. 2 times 4 is 8. 8 plus 4 is 12. 12 minus 2 is 10. Okay, now, a parabola is curved. So between any 2 arbitrary points, we're going to get different slopes of a line. So it will be unique. 10 minus -5 over 2 minus -3. That is 15, right? And then this is 5, right? So the average rate of change between those 2 points is 3. In AB, we kind of analyze this a little bit better, but we only did that in one day. We only did average rate of change. So we got to really break it down. I wish I could talk more about some of the things that we went through. Like it was talking about a Fitbit. You know how your Fitbit, does anyone have like or Apple Watch and it tracks your rate of walking? Anyone ever do that? I have a bike app that tracks how fast I'm going instantaneously. And what it does is really, remember the lady in her equal intervals right there? That app has equal intervals, but probably by half seconds, and it's analyzing my distance and time and the distance I do over time, over and over and over and over again, and instantaneously is changing my rate on my well, it's actually on my phone, and that's what it's doing. It's doing what that lady was doing and breaking down, that curve right there. So kind of really interesting, actually. All right, so that's good. That's average rate of change. We'll come back to that and make more sense out of it. Hey, just throw this real quick. Input, say it. Now, how do I graph these? I'll show you, and then I'll tell you why I chose what I chose over there. And I did this because I know we're going to be short on time. So I'm kind of just slapping some of the notes in your face. So number one, we should remember an absolute value is a V, and the vertex is at 0, 0. So that's where I start my chart. And then I go 2 up and 2 down from there to get the shape and make sense out of it. Absolute value of -1 is 1. Absolute value of -2 is 2. Then those colors over there now gets into the trying to find the average rate of change. Right? So that's what's so bad about this microphone. I should put this here so at least this isn't in your way, is it? Okay. Because as soon as I turn away from the mic, you can barely hear me. All right. Very angry at this computer. Okay, so now let's do domain and range, which I erased it. Okay, what's the domain? The domain are the x's that you can plug in. There are no restrictions. We're going to get more restrictions because you're going to learn about more functions this year. You had some last year, though. Square roots function had some restrictions because you could not square root a negative. That's the kind of thing. But this doesn't have any. And then the range, you have to analyze the picture. This is review, so this is why I'm just shoving this in your face without asking. All right, when you look at this, the lowest y value that exists is 0, and then everything above that exists. 0 does exist on the chart, so it's a bracket, not a parenthesis. So get down the difference between a bracket and parenthesis. We hit that hard last year, and we should make sure we understand that. The only intercept that we have is 0, 0. It's both an x and a y intercept, so whatever. Now, the limits. That's what I have that green line there. I went green on this and did my answer in green last hour. So input, say it, output. So the limits are, this is what the x's are. And I'm going to start with this one, infinity. So as I plug in bigger x's, as I plug in input, output, as I keep increasing the x's, where are the y's going? Where are the y's going? They're going up. Going up for what? For how long? Forever. So if in theory I could plug in infinity for x, I would get infinity for y. I plug in a billion for x, I get a billion for y. So that's what that idea is. When I plug in bigger and bigger negatives, which is the opposite of what I should say, the bigger a negative is, it's actually smaller. Anyway, what happens to these y's as I plug in those negatives? They also go off to infinity. I don't understand how students can't figure that out. My ABers last year, some people missed every single limit question. I'm like, I can't even. Okay, I will do this. Intervals of increase. You're supposed to name the x's that create the increasing y behavior. So this is the x coordinates that create the increasing behavior from 0 to infinity. And then when I plug in these x's in order from left to right, I get this decreasing behavior for the graph. So that's from negative infinity to 0 for the x's. You got to make sure that you get that taken care of. There is an extrema, there's a min at 0, 0. We could use the terminology, it is 0 when x equals 0 as well. Sometimes they just list the coordinate. We're just kind of going through this fast. Okay, now, average rate of change, and this is a V. Okay, let's look at this. That's where I got these blues. I'm going to erase this. I am not going to do what I did in the previous ones by finding the coordinate. We're just going to look at this. So what's the average rate of change from -2 to 0, which means I'm dealing with this coordinate and that coordinate. Hey, everyone, what's the slope of that blue line then connecting those 2 points? What is the answer? It's -1. We should be able to look at that and say, you know what? When I connect those 2 points, those have a slope, which a V is 2 lines connected together. It really is. It's not a curve. It's a linear scenario. It just has 2 different parts to it. All right. And then from 1 to 3, you can see those blues 1 comma, 3 comma. What's the slope of that blue line when I connect those 2 points? 1. So that's the difference. When you flip over to the other side of the vertex, you do have one side has a positive slope, one has a negative. Now, I will say this. What's the average rate of change from -2 to 3? Well, that's different now, isn't it? That would be that line. All right. And then you have a much different answer. Okay. So just make sure you understand that as well. What average rate of change is overall. I don't know about this concavity. I'm going to say up, but it's not really curved. The rest of the year, we're going to be dealing with curves. I think we're just starting with the beginning. Hey, linears, what kind of happens with this average rate of change and all that other stuff? It's curves the rest of the year. Function even, odd, or neither. Which one is it? Even for sure. All right. And then this one real fast. I'm not doing the all those things. I might verbalize them because of time. What time we get out of here? 55, right? Okay, so we got to get rocking and rolling here. But remember this. Why did I choose what I chose in my chart? It's because this is what you should do always in an absolute value, x squared graph that is in vertex form. You plug in the x value that makes that 0 on the inside because by golly, that is where the vertex is located. And then what do you do after that? Go 2 up and 2 down from those x values to get a little shape. All right. So 4 minus 4 is 0 times negative 3 0 plus 7. So 4 comma 7. 1, 2, 3, 4. 7 is all the way up here. 5, 6. 5. 5 minus 4 is 1. Negative 3 plus 7 is 4. 5, 4. 5, 1, 2, 3, 4. And then 3, 4. There's the V. Notice I did my symmetry sound. Okay, so 3 comma gives me the same thing. 3 minus 4 is negative 1, but then it turns into 1 for absolute value. 1 times negative 3 plus 7 is 4 again. Yes, 4, 4, 4. And then 2 comma 1, you can evaluate 6 comma 1. And then you end up getting this V. Now, there are some things on here that we just don't have the time. Domain, all real numbers. Range, though, that's interesting. I will put that down. It's all of these y values all the way down here, all the way up to 7. You are not allowed to say 7 to negative infinity, though. You must say negative infinity to 7. I will mark you wrong so quick your head will be spinning if you put that in the wrong order. All right? Intercepts, there are 2x intercepts and there is a y-intercept. We don't have the time to analyze that. As x goes to infinity, y goes to negative infinity. This, as x goes to negative infinity, y goes to negative infinity. So negative infinity on both of these verbalizing. Intervals of increase, listen, you name the x's. It increases from, I'm trying to yell into the computer, negative infinity all the way up to 4. 4, the x value. The word increase is describing the y already. You name the x's that make it happen. So just make sure you have that. You have a maximum, and then same old, same old. Negative 2 to 0. You'd have like these points, if this continued. What's the slope there? What's the slope between those 2 points? Look at the equation and then take a guess. What's the slope? It's negative. Negative what? 3. It's that multiplier out in front. I meant to say negative. All right? Got it? So the slope between, on the interval from negative 2 to 0 is the negative 3 of that, 3 in front of the x minus 4. But then, I'm sorry, my bad, dogs. Isn't that a positive slope? I heard someone hiccup over there. All right? You got it. You got it. You got it. You're right. All right. And then from 1 to 3, well, look at this. From 1 2, 2, 3. What's that answer as well? Same thing, 3. We never flipped over to the other side of the vertex. So both of these are positive 3 as rates of change there. I guess we'd say concave down, although I kind of question that when it's not a curve. And then even out or neither. What is it? Even out or neither? Neither. That's why even and odd, they're so unique. There's barely anyone that's, there are barely any functions that are even or odd. Most are not either. Okay, and then just real quick on this one, can you determine the average rate of change for half blah blah on the interval 0 to 2 without using the average rate of change formula? By the way, what is the vertex of this? Where is this located? Where's the vertex of this located? What did I tell you to plug in first? What value for x? Negative 1. So the vertex is at negative 1, negative 3. So negative 1, negative 3 is where this thing starts. And then this is actually the slope. Which way is this going? Up or down for a V? Up or down, up or down, up or down? Up. You better say up fast. It's a positive 1/2. Rise 1, 1, 2. That's what this would look like. It kind of looked like this. All right, real quick. So from 0 to 2, what's this slope right here? Is it 1/2 or is it negative 1/2? Which one is it? It's 1/2. So yes, I don't need my slope formula to know this. I just need to know what side of my V I'm on. So when you're finding average rate of change of linear scenarios, it's just the slope that you're dealing with. Curves, different. And I think we're going to get to that right now with this. And actually, I did get down to this. I graphed a couple of these. Actually, I just graphed this one. And then I talked about graphing quadratics, and you can get some of that done in your homework. What do we got there? All right, 47, we're okay. Input, say it. All right, now we got curves. So 0 squared, 1 squared, 2 squared is 1, 2, 3, 4. 3 squared is 9, which is a little bit off the thing. And then negative 1 squared, negative 2 squared, negative 3 squared. Now we got curvature. Ah, the screen's really slippery too, so it's kind of hard to write on it. All right, so now that is different. When I find average rate of change, I mean, heck, if I find average rate of change between these 2 points, that's way different than these 2 points. This is a steeper line. Way different than the average rate of these 2 points or these 2 points. You're going to get a whole bunch of different average rate of changes now because it's a curved scenario. All right, domain and range, I don't feel like writing it. All real numbers. Range is 0 to infinity with a bracket again. Intercepts, we got a 0, 0. End behavior, not writing it. As x goes to infinity, so does y. As negative x goes to negative infinity, y goes to infinity. So limit. Know that limit notation. I actually do have it over here, so I will write it. End behavior down here. These are both infinity. All right, so they're both good there. Know how to write this notation. Oh, Mr. Stranowski. All right, intervals of increase and decrease. Decreases from negative infinity to 0 for x, increases 0 to infinity. All right, average rate of change. That's what I'm really concerned about. Here's negative 2, comma. Here is 0, comma. So you're finding the slope of this line. That's what average rate of change is between 2 points on a curve. Well, this is easy. I don't actually have to do my, I could just do my counting. 1, 2, 3, 4 over 2. So this is negative 4 over 2, which is negative 2 is the average rate of change. Got it? It makes sense? But then the average rate of change from 1 to 2, 1 comma, 2 comma, is this line, which is a little bit steeper. It should kind of fit in that inside and then hit the outside there. But you could just do drop 1, 2, 3, and actually, and then run. So it's actually positive. Or rise 3, run 1. I hope I got that right last hour. I feel like it. I don't remember saying 3. But y equals 3, right? Or m equals 3, not y equals. Definite concavity. This is concave up for sure, and definitely even, odd, or neither. Which one is it? It's an even. Okay. Going to this one, this just flips it upside down and makes it skinnier. I doubt I'll even cover that one. On Monday, we'll probably just go to the table of values and analyze first and second order differences. And related to the second video, the lady, those equal intervals that she chose for the x value to see what's happening with the y value. But I want to remind you of this. When you get to this page, you don't have to do your notes, but I think you should be able to do your homework. I think you should be able to graph any quadratic in your homework if you just listen to what I say here in the last 4 minutes. This is vertex form. So when I do my chart of values, what's the first value I should plug in right here? What value for x should I plug in? Negative 3 is correct. You get the 0, and then you do 2 above and 2 below that to get 2 other points, and then you'll see the parabola. This is the vertex. This is why this is called By the way, the vertex is negative 3, 5. You're going to get an output of 5 when you plug that in. The problem with the next one is you got to remember this. This is a magic formula, which is part of the quadratic formula. The plus minus square root part is actually how you move right and left from the vertex x coordinate to find the x-intercepts. I'll prove that on the third one that I show you. You guys remember that? Negative b over 2a? You get that number, and then you plug it in to get the y coordinate. And then that's the value that you put in the chart in the middle. Whatever you got out of negative b over 2a goes here. You go 2 up and 2 down and go from there. But actually, the y-intercept's real easy on this too. It's 0 comma negative 5. So that's also a valuable point to find as well. The last one, this is intercept form. Notice what I did. I left them there. So remember intercept form, you plug in negative 4 for x, you get 0 for y. That's why negative 4, 0 is an x-intercept. You plug in 2 for x, you get 0 for y. All right. Now, what's the vertex's x coordinate? You should be able to tell me what it is on this picture. What's the x coordinate's vertex? What's the vertex's x coordinate? What number? -1. The vertex is right in the middle, the x coordinate. Now, it's not there. It's -1, comma. You got to plug it in and see if it's above or below. Where should the y coordinate be for this vertex? Be above or below these points? Below. Why? Which direction is this going? Up. So the vertex should be somewhere down here. So this is graphing 101, just remembering 11 months ago, probably. It literally probably was in September that we were graphing quadratics in all the different formats. Or maybe we solved and then we graphed. I forgot the order of things there. And then what's left over is, well, look, you might be able to do that now after you've graphed those. So I think you really could do about 85% of your homework, and then I'll talk about first and second order differences on Monday and continue. Okay? All right, thanks for being cool about listening. I know this is tough, a lot of information to be shared.